Very good morning, people. Yuga, good morning. Purnima, good morning. Durvesh, good morning. Manasi, good morning. Devrishi, good morning. Prajwali, good morning. Prajwali, good morning. Tejas, Kriti, Praveen, Pranav. Anuja, good morning. Mitali, Ashutosh, good morning. Prachi, good morning. Om, good morning. Pragati, Sakit, Gaurav, good morning. Swarada Joshi, good morning. Ritesh, good morning as well, and Maitri, good morning as well. Just give me, you can see I'm not at my regular place today. I was a bit hurried up. Let me just adjust my mobile phone for our lecture so that I can see what you are seeing as well. And there should be no lag in what you are seeing and I am seeing. So, yeah, Nikita, good morning. Prathamesh, good morning as well. Uh, I don't know how many of you all were attending yesterday's evening session as such, and as reports show, and many of you all did respond afterwards as well, that it was very interesting, and I had assured you earlier that yes, it's going to be infotainment guaranteed. Infotainment means information as well as entertainment. Having said entertainment, of course, you may have realized that it was not absolutely and all about entertainment. It is more of a sensible information that we need to know. Okay, and Akshay, good morning. Both Akshay's good morning. Aishwarya, Asmita, Harshal, Akshay, the third Akshay. Oh, Relekar. Oh, sorry, he's done it double. Ajit Kadam, all of you all, good morning. Well, so that movie Home, it has always struck a chord with the geographer in me, and that's basically because, as I said, and if you can read about it on the Google also, that way back in 2009, okay, they shot it in complete HD. HD was a new technology then, and all of it was done live, and of course there is hardly any animation in that. Okay, and a lot of multinationals did contribute towards the happening of that particular documentary as such. um, we are going to place or make our assignments based on that. Of course, I will be speaking about it later today. Ishwari, Sandesh, good morning. I will be speaking about it as to how that is going to go about last time in the evening session when we meet once again at 6:30 to see the latter half of the um, the document. Well, we were speaking about the theories of crustal formation, and yesterday we spoke about the tetrahedral theory by Lothian Green. But as we know that he had suggested a geometric model which was not stable, and that's why his theory got say sidelined. And then we have isostasy. Isostasy is more of physics, I would rather say, and that's why you'll see that one discusses about it quite separately. What comes in a so to say sequence is something that starts with the continental drift theory in 1912, and I did mention yesterday that they had an English translation of the same because Wegner was a German, so English translation came only 12 years after that, and all those things that we have done yesterday. We need to go further into what Wegner has to say about it. But one thing that I wanted to mention, I don't know whether I've mentioned it earlier as well. It struck me when I said that Lothian Green presented the theory of tetrahedral or tetrahedron, the Earth being the shape of a tetrahedron. Since then, you'll see that scientists have tried to finalize the shape of the Earth. You'll see that generally we say that the shape of the Earth is round, but when you start learning geography and when you attend your higher classes, we know that it's not an absolute round, or to be real for the physics sense of it. It's actually a sphere. It's not a round. It's a sphere. Then we go ahead and say that it's not an absolute sphere. It's I would say flattened a bit at the poles, and it's bulging at the equator. And off late, if you search for a term called as geoid, Geoid, in the dictionary, you would say that that is the Sarthak, good morning. That is the special term which has been coined to explain the shape of the Earth. Now, what exactly do we mean when we say the word geoid? It's basically, see, the Earth looks round basically because it has 75% of liquid on it, and we all know that liquid takes the shape of the container in which you are going to pour it. And as far as the liquid on the Earth is concerned, the speed of Chinmay, good morning. The speed at which the Earth rotates and revolves around the Sun, we have seen this in earlier lectures as such. The centripetal and the centrifugal force keeps the surface of this liquid very plain, and that's why when I'm going to look at the Earth from outer space, it would look more or less like a sphere to me. As I come nearer, I know that the poles are flattened and the equator is bulged, but when we talk about the shape, of course we should be talking about the shape minus the liquid, isn't it? So when I am going to draw out all the liquid on the surface of this particular planet, I'm going to be left with a solid shape. Now that solid shape of the Earth is called as geoid. Okay, so let us be very clear of the latest terminology used as far as naming the shape of the Earth is concerned. It is a geoid, which is that part, the solid part of the Earth, minus all the liquid onto it as such. So that is as far as geoid is concerned, and that was a point I wanted to make as far as the shape of the Earth is concerned. Now, coming back to Wegner, and let us go to the slide. Okay, I'll take up the PowerPoint. So yeah, so we spoke about this, and we are going to come back to this particular theory of plate tectonics because it's the latest that we tend to speak on as far as what is happening with the crust of the Earth. But going back, fast forwarding back into what happened 100 years ago is something that we need to go into what is called as the continental drift theory by Wegner. Of course, the happening went back much more in as far as the geological ages is concerned. Yesterday, I did mention about Pangaea, which is the supercontinent at one point of time, and this is around 300, 350 million years ago. That equates to the Carboniferous period in the Paleozoic era as such. I did say yesterday that yes, this is not the only time that the Earth has put all these blocks together to form the single continent of Pangaea. It is believed that it happens every 1 billion years, and possibly there have been two rounds of unification of all continents, called as Rhodania 1 and Rhodania 2. And Rhodania 3, incidentally, is now called as Pangaea. Okay, that's basically because Wegner named it as Pangaea. Okay, some people pronounce it as Pangaea. We as Indians could pronounce it as Pangaea as such. And this existed for a significant period of time. But as I said yesterday, that before anyone goes into establishing or propounding a theory, he or she would obviously be giving you some postulates. Now, these postulates, interestingly, are based on obviously what the person is thinking and what profession the person comes from. Wegner, let me tell you, was a climatologist. He was referring to climates in different parts, and this was with reference to the fossils and the vegetation that he was finding in different parts of the world. Now, as contrary to his observation, he found that there were some contrary observations in contradicting rather observations that a climate of a particular type was giving him fossils of an absolutely different type. Um, and two things came out of what he was to propound. He said that if I'm going to have very wet fossils or fossils of animals from wet climates in deserts, that means that the climates are changing. He says that that is not a true, that cannot be true basically because climates don't change, is what he said. The second option he said is that in that case, if climates are not changing, then possibly the continents are moving as such. I did refer to this yesterday also, that he should have said that it could be some part of climate change and it could be some part of continental movement, but he absolutely discarded the theory of climate change and he went with the theory of the continents on the move as such. That was the first postulate. He made it a base of his theory that continents are on the move. Okay, this was in fact heavily criticized later on. Then he said that as far as the continents are concerned, what are continents? They are the Sial. What are oceans? They are the Saima. And the Saima is denser than the Sial. And he says that it is basically on the Sial is riding on the Saima, and that is how they can easily float, is what he says. Now, this movement, he says, it was in two patterns. Some of the continents, he said, say, were driven towards the equator. Now, later we know that, in fact, as far as the Indian Peninsula is concerned, it came up somewhere from somewhere of present South Africa all the way crossing the equator, and it's above that also. So, how much we need to believe, or we need to say agree with Wegner is a different thing. But he says that some continents moves toward the equator, and there were some continents which drifted westward. He identifies this in a term called as Paul Flucht, because he believes that this movement was basically riding the continents away from the poles, away from the poles. Now, going back to what Wegner has to say, he says that you have one Pangaea. It gets, over a period of time, it gets divided into two. The Laurasia, yesterday I said it's a bit smaller. You have the Gondwana, which is a big, sizably larger as compared to Laurasia, but both of them are separated by what is called as the Sea of Tethys in between them. Now, the Sea of Tethys is basically separating them, and they are more towards the poles. He says that later on they are going to move towards each other. That's the Laurasia and the Gondwana, and that is what he calls as polyfluct. And then you'll see that it is the Laurasia separately and the Gondwana separately which are further going to break. And he says that he confirms that they have broken, basically because he says that if you look at the world map of today and you push these continents together, they fit into each other, what he calls as a jigsaw fit. Jigsaw fit is another term which is absolutely related to what Wegner had to say. So this is say these are the two things that the moment you hear polyfluct, you have to say that yes, this guy is referring to Wegner. The moment somebody says jigsaw fit, you have to confirm that this guy is referring to Wegner as such. Now, with these postulate, Wegner goes ahead. He was a prolific traveler, let me tell you. He traveled from one place to other throughout his life. And yesterday I did mention that he lost his life in one of his travel voyages also as such. Okay, you'll see that you can see that the Sea of Tethys, and then you have the separations. You have the Laurasia up, and you have the Gondwana land, which you can see here separated down in two formats. Now, the shadings there, okay, these are the ancient rock assemblages, you could say. Okay, and this is Wegner, who is working in his I suppose his study room as such. Okay, and this is how he says that these tend to, this is the present scenario, and they were possibly together at one point of time. Now, obviously, you say when a scientist puts forth something, he has to have evidence to that, isn't it? So obviously, everybody was asking him for the evidences when he started presenting his theory as such. He said, "Yes, I have my evidences with me," and he gives us four basic evidences. What are these four basic evidences? The first one, the term that he uses, jigsaw fit. You can see this towards the right of your screen also. That if I pull the North and South America eastward, and I push the African continent westward, they are going to match into each other. In fact, the belly of Africa, as it is called, it fits into the Gulf of Mexico there as such. So they come together and they could fit into each other. That is what he says, that if you look at the geographical similarities of the outlines of all these continents as such, they fix into each other. And that is my first evidence. He says that yes, At some point of time, all of these could possibly could have been in as a one unit as such. He does not stop there. He says that I have more evidences. He says that look at the rocks at the coastlines of both of these. He says that there is a lot of geological similarity as far as these rocks are concerned. So a possible reason, he says, that they could have been joined at another possible reason, I would rather say, that they could have been joined together also as such. Then he says that when you look at glaciation evidences, particularly in Gondwana, because he says that Gondwana was a bit south before it broke up and it started moving. So there are glacial evidences, and these glacial evidences are say true and parallel in various continents. They are the same evidences of glaciation in South America, Africa, and of course in Australia. And more so, he says that what you find in India is very, very striking. Okay, so that is another glaciation evidence. The fourth evidence, he says, is basically based on fossils, and this is very interesting. He put forth. We'll see that as far as, of course, just like rocks, there is going to be a similarity as far as fossils also are concerned. But what he says is that as far as these fossils are concerned, the fossils on the eastern coast of South America and the fossils on the western coast of Africa as a continent, for example, let us say, are very peculiar in the sense, he says that if we go by the normal scenario, the fossils obviously should have been marine. But you'll see that some fossils, of course not all, some fossils are fossils which are supposed to be land based fossils. Now this is going to fit into the picture only if you put South America and Africa together, and then you say that yes, this is a whole piece of land, and then you could have a fossil which is of a land animal placed on that as such. Okay, then he speaks about various other fossils, and he gives explanations to all those things that may have happened as far as the accumulation of fossils in different parts are concerned. It's very interesting to note as to what exactly lies on the continent of Antarctica, because presently Antarctica has heaps of snow, or I would say ice sheets on that. It's only, it would be wise to take samples from the bases of Antarctica to note whether we have say any fossils there. And obviously, if we can't do it now, it was out of question of Wegner doing it 100 years ago as such. This is the evidences, he says. And then he says that well, what has happened is around Carboniferous period, all these continents were together. He called it the Pangea. This is the flow of his theory. He says that a few million years down the line, say start of the say the Triassic period, that's the Mesozoic era. They split into two, and it's separated by what is called as a shallow sea. It's not a very deep sea. He calls this shallow sea as Tethys. So now Pangea is one word. Then you have it splitting into the northern Laurasia and the southern Gondwana. And then in between them, you have a very shallow sea, which is the Sea of Tethys as such. Now, eventually what happens is the say the erosional material from the Laurasia as well as the Gondwana is going to be eroded and is going to be deposited in the Sea of Tethys. And what is going to happen later is what he interestingly puts forth as such. He says that there is not a significant movement after uh, the initial breakup, but say towards the end of the Jurassic period, he says that there is again some tectonic movement. Of course, he did not call it as tectonic. He said the continents start breaking up. The Gondwana breaks into South America, Africa, Australia, Antarctica, and peninsular India separately. And the Laurasia breaks into North America, Asia, or rather Europe, and the northern part of Asia. I would say minus the peninsular parts of India as such. And then they start moving as such. He says that you have evidences of the poles moving, and he calls it as polar wandering also. Okay, you'll see that even today, you'll see that you can't confirm the magnetic north and south pole of the Earth at one particular point. It keeps on shifting, and I said that this shift is basically because of you have a core which has an outer shell which is liquid, and you have an inner shell which is solid. So it's the dynamism between the outer core and the inner core, which is going to yield you a lot of movement as far as the magnetic north and south are concerned. In fact, every 3 to 4 lakh years, it is believed that the Earth shifts its magnetic pole. So, what could be the north magnetic pole 3 lakh years ago could shift to the south pole to be the south magnetic pole 3 lakh years down the line. What is interesting and alarming is for the last 7 lakh years, it is believed, for the last 7 lakh years, the Earth has not shifted its magnetic poles as such. So we could say that it's time that the Earth is now ready to shift its poles once again. I don't know what would happen as far as say the event if the present North Pole happens to be the South Pole and the present South Pole shifts to be the North Pole. It's going to disrupt a lot of things, right from the satellites which are based on this to the birds which fly throughout the winter from Siberia to the say the southern latitude, southern in the sense the lower latitudes, and then they go back. All these is done with referencing to the North Pole as such. Now, if this shifts, it's going to be a very weird situation for all of us on this particular planet. But let me tell you that this doesn't happen suddenly. That it doesn't happen that yesterday you are sleeping, that 15th of December you are sleeping, and 16th of December all of it has changed. It's going to happen gradually, and it's going to take at least thousands of years, if not millions. Of course, it doesn't happen in millions of years. It at least it would take a few thousands of years as such. He puts forth characteristic features of other animals also. He typically refers to a peculiar type of an animal which tends to go westward in say the northern part of Europe as such. Now and he says that these animals run and they dip into the ocean. Now there is a this was a very difficult behavior to understand. He says that this can be understood only if you say that this particular species of animal had an habit to go all the way along the west, and this would have been possible only if the North American continent and the European continent were together, and it's only in that case that this animal could possibly run across the landscape. Okay, it has been its intentional habit, but now it does not realize that they have been separated by at least 7,000 kilometers as such. So there are several such examples that Alfred Wegener quotes as far as his evidences are concerned as such. But there are a few things, of course, as a scientist, you have to be very confirming as such, and you should be able to answer all the questions that come to you as the form of criticisms as such. Now, there are a few things. Initially, you'll see that 1924, say for example, is a period which is between the First World War and the Second World War. And you'll see that Germany and England have not been very good friends during the First World War and the Second World War as such. So obviously, when his theory tend to be say translated in English, the English scientists started looking for loopholes in this particular theory, and they came up with a long list of criticisms that they just threw upon at Wegener as such. What were these criticisms? The first of the criticisms they say is that how do you explain the forces that push North America and South America westward? How do you explain the forces that push Africa northward? How do you explain forces which makes India travel so long? It was amongst the fastest of the traveling land piece. Okay, with a speed of around 26 centimeters. If you calculate it, it comes to 26 centimeters per year. Now, 26 centimeters is what, less than a feet, but for a landmass of the size of India, it is going to take a lot of time. I have my personal belief that because it is so small as compared to the other continents, it could travel the fastest. And then, of course, the question was that how did Antarctica got pushed towards the poles, and how did Australia get its position of now traveling for so many hundreds of kilometers as such? I think I forgot telling you that the forces he says is some gravitational forces for the movement of these masses, or land masses towards the equator. And then he says that it could be the tidal force of the sun and the moon, the tidal forces of the sun and the moon, which possibly push the northern and the southern American continent towards the west, is what Wegner has to say. But the counter argument to what he had to say is that the scientists say that, okay, even if we agree to the the centripetal forces that pull the continents towards the equator, if you say that the westward movement, of course, they did not agree to this varied movement as such, but they said that, okay, if even if we agree that North and South American continent were moving towards the west because of the tidal forces of the moon and the sun. They say that if you calculate the amount of force required for these continents to travel the present distance all the way to the west, that gravitational force, or the tidal force, okay, tidal in the other word means gravitational force of the moon and the sun, this could have brought the rotation of the earth. This at least could have slowed the rotation of the earth, and some did say that in fact it could have stopped the rotation of the earth completely. So they did not agree with the forces that he was explaining. So that's one of the first say answers that he was not able to give as far as the criticisms were concerned. The second, they say that, well, on one side, you say that the Sial is riding on the Saima as such. It's riding in the sense it's floating on the Saima. Now, if something floats on something, some other substance as such, on one side, you say this is happening. On the other side, you say that it's basically all the material that lies in the Sea of Tethys between the the Asian continent and the Indian landmass as such. How could it? Now, it's not only the Himalayas. They also refer to the Rockies in North America. They also refer to the Andes in South America. And they said that if this is supposed to be happening, you don't give us that amount of force. You are not explaining us that amount of force. If it is just floating, they say that it is just impossible for the Rockies and Andes to rise up to a height of 5,000 meters. And in fact, it is further impossible for a mountain chain like the Himalayas, which is say 2,500 kilometers across and as high as 8,500 meters. Of course, it's only last week I think it's just 10 days ago that the world confirmed the height of the Himalayas having risen by 0.86 meters. That's by 86 centimeters as such. But scientists said that either of these statements should be true. Both of them cannot be true. You say that the Himalayas are fold mountains which have come up because the Indian plate has pushed into the Asian plate. Either this is true, or the fact that the Sial is floating in the Saima is true. Both of these conditions cannot be true. That's the second criticism, and he was not able to give, I would say, satisfactory answers to that as well. Then the third thing, they say that, okay, you say this is that and that is this. Let us come to facts. They say that well, if I am going to cut the shapes of the continent, and let us see if they match as you say that they fit into the jigsaw fit and all the model that you are referring to. They actually did cut it into the shapes, or the present shapes of the continents, and they said that, okay, now see, if I'm going to put them together, they are not actually matching. If you say it's jigsaw fit, it has to fit as a jigsaw. These continents are not matching as jigsaw. Okay, again, he did not have an answer to that. One drawback, I would say, as far as Wegner was concerned, and he had to heavily pay a price for that later, is people, present scholars say that he behaved more like an advocate rather than a scientist. A scientist will say that, okay, this is my theory, these are my postulates, these are my evidences. Okay, you are giving me criticisms, let me work on them. Okay, so a scientist would do that way. What does an advocate do? He tries to drive home the point, and he tries to prove his point that, no, I am right. He will take whatever is going to be helpful as evidence, and he will hide something that is not going to work against him, rather with him. And the same thing happened as far as the Sial Saima flotation concept that Wegner had given. And here is where he fell into the trap. He was fighting his case as an advocate. He should have said, okay, I may have fallen short of explaining this. Let me go back to my lab and let me work on this, and I'll come back. He argued with people that no, 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 what I'm saying is right, and what you're trying to say is not right. Okay. And then people used to catch him on the forces issue, the forces which made this move issue, and of course his basic postulate or the Sial moving on the Saima as such, and he had no answers for that. However, let me tell you that eventually his theory faded into history, partially, I would rather say. I think, I'm not very sure, but Wegner experienced a tragic death somewhere in 1926, and not many proponents took his argument that seriously after that. But you see that it has been a very important linchpin for the theories to come after that. And that is why plate tectonics gives it its due reference as such. And whenever we speak about crust and crustal formations, Wegner is the first person that we salute as far as discussion of the movement of the continents is concerned. And that is why you'll see that there has always been an attempt, even in the present era, there has always been an attempt to try and confirm the theory of Wegner, because now we know that yes, the continents are actually on the move. So where did Wegner go wrong? What were the shortcomings that Wegner referred to? And can we solve these shortcomings using present technology? 100 years down the line, can we use that? In fact, it did not take 100 years. It was just a few decades after Wegner, that is around 1960, that a lot of confirmations came forth as far as Wegner's theory was concerned. The first thing is, now with satellite imaging, etc., you have computer graphics, and you could just take photographs of the continent from the space, and you'll see that if you match the continental shelves, okay, the present shape of the continent is with reference to the present sea level, isn't it? If we are referring to a different sea level at a different point of time, you'll see that the present continental shelf, okay, which is below the water presently, could have been above. And it has come to fore that these continentals, if you take the shape of the continental shelves, they do match each other. Again, not exactly as the jigsaw fit, basically because it has been millions of hundreds of millions of years that this has happened. So there is going to be a lot of erosion on the land, and this eroded material is going to be deposited in various forms of deltas, etc. So it will not absolutely match. But yes, what we can prove that what Wegner was saying was actually making sense as such. So, see, his theory of jigsaw fit is very nearly accepted, I would rather say, by majority of the scientists as such. Then they have gone to see the geosimilarities that are there, the geographical similarities, the rock similarities, etc. And then there are two theories. Okay, I think one is by Harry Hess, and the other name I forget. Just if I recollect, I'll come back to that. But you'll see the two theories of paleomagnetism and sea floor spreading. Of this, I'll take paleomagnetism today. In partial, of course, we don't have it as a part of theory, but to confirm the connections between Wegner and plate tectonics, we had to refer to this. Now, what is this paleomagnetism? If you remember, I said that the Earth shifts its poles, the magnetic north and the magnetic south, regularly. So for those 3 lakh years, that the magnetic north could be the geographical north, and the next 3 lakh years that the magnetic north actually could be the geographical south. Now, for 3 lakh years, remember, there are going to be a lot of volcanoes that are going to take place, and a lot of magma is going to spew up, and this magma is going to say cool down as lava as such, and this is going to solidify in rocks like granite and basalt. Now, there is a lot of iron in basalt. Now, it was seen that the iron content in the basalt, it lines with the magnetic orientation of that particular time. Now, what does that particular time mean? When this rock actually came up as magma and cooled down as lava as such. Okay, and it was found that if you take strips of land, particularly with reference to the oceanic ridges. Now, where do you have these oceanic ridges? Let us go back, and I'll give you one of them. Let us see. Yeah, if I am to, okay, you'll see that this is, say, for example, the mid-Atlantic ridge. Okay, now if I take rock samples from this side, that's the right side of that line, and the left side of that particular line, I would see that there is a similarity as magnetism is concerned. But then I go further away from this, the magnetism has reversed. And I same way I go to the other side, the magnetism has reversed, but this magnetism and this magnetism is the same. And that is why you see that this let me come to that diagram if I am able to. Yeah, if I'm to confirm this particular diagram, you'll see that the central part are same, and then you have the white part is different, and then you have the another small part. Now they are thicker or smaller dependent on how fast the magnet, say the polar magnetism shifted. It is not like clocks that the earth says that okay, it is 3 lakh years now, let me shift again. After 3 lakh years, the earth just rises up in its deep sleep and says that okay, let me shift. It happens, it is so very natural. So at times it could have been like presently for 7 lakh years it has not happened, but at times it could have been within 3 lakh years, it could have been 2 lakh years. So the strips of magnetism could be different, but what is true is that there are alternating, these magnetism strips are alternating. So the paleomagnetism theory, to quite an extent, confirms with what Wegner had to say. Now, what I'll do is I'll stop sharing now. I'll let you know the reason for that. The reason being that you know that I am in college and I have some meeting to attend right now, and that's why I would continue this for another 5 minutes. If you have any queries of what we were doing yesterday, if you have any problems with regards our evening sessions or whatever I have been saying about Wegner and his theory right now, for the next couple of minutes, let me address to any queries you possibly may have. Otherwise, at around 10:10, I would be closing this lecture for this for today as such. So, if you have any questions, you could just put down your queries in the chat box. I would look into that and I'll try to answer your questions as such. I hope you have understood what Wegner had to put forth. It starts with his belief that it's the continents are in a jigsaw fit, and from there he starts collecting evidences, and then he says that once upon a time all the continents were together, and then this split. The first split was into two blocks, and then the two blocks he named as Laurasia and Gondwana, the Gondwana being larger of them. Between them, you have a shallow sea, which is called as the Sea of Tethys. They split further by the Mesozoic era, and he says that as far as the Himalayan chain is concerned, the Himalayan region starts its growth, say by the late Jurassic. It continues into the tertiary period, and in fact, we know that the present earthquake activities that you see all along the chain of the Himalayas, it's so very possible that the Himalayas are still into formation. That means that the formation of the Himalayas is not absolutely complete. It's still dynamic, and it could grow further a few meters, let us say a few thousand years down the line. So if you have any questions, I'm still waiting for questions. If you don't have any questions, I hope you are getting your credentials registered. If you still don't have your credentials, you could please send your information, personal information, to Professor Devte, who's the Vice Principal Science, because in this week I would possibly try to shift to G Suite because that's more convenient. Yeah, I have a question. Mayuresh Yadav says that which was the video you shared today at 6:30? I was not able to. Today? No, yesterday. This was yesterday evening 6:30. Okay, and I will be sharing the video after we finish screening of the full home documentary in the evening today. I see. Yeah, Ashutosh has a question, sir. In some last lectures, we are learning from PDF in which some geographers' details are there. My question is, what will come in the exam or not? Don't worry. For FYBSc, you would not be, we would not be, I would not be asking you questions on the details of that. It's basically, you'll see that geography is such large scope: human geography, physical divided into four parts, human divided into four parts, the modern forms of geography, use of satellites, use of aerial photographs and all that. Okay, it makes so vast that at times, if you do it in bits and pieces, you don't get the essence of what actually geography means. That is why I thought that, okay, I should be giving you a complete sequence of what actually is happening in geomorphology. You don't have to learn Herodotus and what he had to say and what he has done. Don't worry about that. Your questions would be very, very basic as such, and very corely related to your syllabus. Don't worry about that. It's going to be related to what I'm doing in my lectures, minus what is obviously not there in your syllabus. So don't worry about that. It was, yeah, Maitri was just, I think, explaining to uh, what Mayuresh was asking for. She says that it's Jan Arthurs who has, I think he is the director of that particular thing. So anyway, anything else than what we were discussing? We could, in that case, stop, and I have my meeting, as I said, at 10:15, so I would have to close down the lecture right now. In any case, if you come up with a question after that, we always have a WhatsApp group. You could just put on your questions on the WhatsApp group as well. Thank you for being there for the lecture. I'm going to end my broadcast right now.